We have made it to section 1.3. Is really about calculator skills and memorizing the shapes and properties of basic functions. So to start off with, in our section, we have a definition, and a definition is something we've mentioned already in class. It's something called a continuous function. A function is continuous on an interval if it can be sketched without lifting the pencil from the paper. So starting on example 1, we're to find the intervals of continuity and the points of discontinuity. Now notice that writing. Continuity is an interval. We're going to talk about it as we move across the graph from left to right. And then discontinuities happen at points. So starting with the first one, we notice that there's a break here. We'd have to lift our pencil if we were graphing on that one. And there's a break there. So those are our two locations of discontinuities. So in this case, we have a discontinuity at x equals 0 and a discontinuity at x equals 5. That means that the function is continuous from a -6 to that break at 0, and then we can graph some more between 0 to 5. And then we have a break at 5, and it picks up graphing again to infinity. On g of x, you notice as you trace it, there are not any breaks, so this function is continuous. And it is continuous from negative infinity to positive infinity. Okay, so there's our discontinuities. On h of x, we have a basic sine wave graphed, and you notice as you're graphing it, you come to a break here. It's a simple break, but it's still just an open circle. And we have a break here as well. So those are our discontinuities. The breaks happen at x equals -4 and x equals 1. The continuous region would be from negative infinity to that first break at -4. Then we graph from -4 to 1. And then we pick up graphing on the other side of 1 to infinity. Finally, this last graph, k of x, has a vertical asymptote. That's a place where the domain does not exist, and it generally happens in this class when we divide by 0. This vertical asymptote happens at x equals +2. So that's our discontinuity, and it is continuous as I graph it from negative infinity all the way to 2. And it hops on the other side of that vertical asymptote and starts graphing up here, and it just keeps going to infinity. So there's our discontinuities and our continuous intervals for our first example.